Testing. Okay, we're back with the 127th script. This is continuing with the ModeLab series, which are just incredible. Around 2012 to 2015, they've recorded them. I'm actually going a little reverse order back to the introduction of Python, and we'll take a look at what they have to offer here, which is pretty awesome. I had to correct a few scripts for my own liking, maybe just having to bring things up to speed, but let's have a look. The first script they have is fairly simple, and we'll put it on so you can see what I'm looking at. It's basically, so let's take a point and make a sphere out of it. That's exactly what they do. And they say, well, how is that scripted? How do we actually see that? So they went into their Python script. They have a radius that they can change the size of it. And they decided, in doing so, you have to go into your Python node, which you'll see right here. And it will set things up for you. And you definitely have to go in, you have to change the names of things. You have to set the type hint, so what it needs to be. And since it's a float, you do a type hint and go over to a float, which is what this one's actually been set as. Type hint and float. There you go. And I outputted spheres, which means in the script, I wrote in, basically, I did just to test the output, I always put in print hello world. You have to type in import Rhino syntax script as RS because that's what you'll be using. You're not writing this in Rhino script, you're writing it in Grasshopper using Rhino script. So initially, if you're in Rhino, you can go into Tools, and you can go into, let me think for a second. Oh boy, why is my mind going a little blank right now? I thought it was in Tools. Yeah, there it is, Rhino script. You could run and edit Python script. You can go in and type your Python through the edit tool and then write all of your Rhino script in here. Once these scripts work, you can cut and paste them over and do some minor adjustments over in Grasshopper. I'm not sure why my mind went blank. Could be it's just the morning. I haven't been doing a lot of that, but I've begun learning the process of Rhino, Python for Rhino. And there's quite a guideline, about 115 pages that you can get in and learn quite a bit of the Rhino syntax script. And I thought doing that alongside the tutorials on YouTube for Python and Grasshopper would be a great idea to get my head around. Building my awesome list and setting up a list, because you've got to know what kind of type things are. And then doing an iteration for I in range 0 to 10, create my point at I, 0, 0, so I is always in the X axis, and you'll see that when we actually play with the script here. When I go in and actually slide around, if I can go in and find my point, it should be on here somewhere. There it is. Actually, it's a little more complicated because I'm showing everything. If I go in and pull my point right there, and it's been made into a sphere, I can actually control those points as they come in and the radius of what they are. And there they be. I'll then, I think what I'll do is condense my Grasshopper script, maybe condense my Rhino script, and allow us to see our Python script in the middle a little better without going that huge. There we go, just pop it in here. After you've created my point at I00, you want my radius to be radius because you have to set your variables to the exact language of what's coming in. It doesn't matter what you call the sliders over here, like sphere radius. It really matters what you input on your in your variables coming in your inputs on your Python node. Just think of it that you're making basically this node above, this sphere node, but you're writing it your own way. You'll see how they change subtly. Then my sphere, right? Rhino script add sphere, and it needs my point, and it needs my radius. Technically, this is all you really need to get this initial script running, is it basically needs my point and my radius. And then my awesome script can be appended, which will actually make this item into a list, as opposed to a single item coming out. And I didn't bother with their first script. I actually thought the first script could be processed until you end up seeing that. A nice little script, there it is. You can save it wherever you want to save it. And definitely you can cluster these little things up and pop them into your components. If you really like what you made in the Rhino, we're going to show that a little later on. You can actually go into File with Grasshopper and make it create a user object out of it. Okay, well, let's hit OK and get rid of that one. Got a little object here that should probably internalize so you're not confused over it. And until I do that, I think I'll just hide that little object we don't need to be looking at. The next script they go into they show the sphere again. It would be a sphere from that point. It's disabled. It's not disabled, but preview on. You can see what's going on here. The sphere. Point, sphere, node. I'm not sure where that one's hidden nodes, obviously. Oh, there it is, way over there, hidden, tucked away, off to the side. But this script is using a different information. It needs radius, it needs spacing, and it needs a number count. So the script you could actually gain control over, deciding how many spheres you want in the count. And that's exactly being used in the input num. The spacing has to be kept exactly in radius, and when you zoom in, you can see you can add and you can subtract inputs as much as you want. You can also do the same for outputs. So we're trying to write a script that's going to take in this data, radius, spacing, and num, and turn out spheres. We're at 6 minutes, so we better get rolling. And here's the script. Once again, print hello world to test it. I did learn about going down here for a sense of kind of debugging. I would have it print throughout this script. I've got it printing every time it does an iteration. It'll print my point. So I have that up here as output to kind of see if my script is having any trouble. You don't have to do that. But basically, my awesomeness is a range from I from 0 to num. So it's not 0 to 10 or fixed. It's actually tied to this sliding integer. And then my point is set to spacing times I on the x over to the y. And so this makes sense to make it more parametric. It's exactly what you're doing in Grasshopper nodes, but you're starting to write a whole script in Python node for Grasshopper. My radius is radius, and there it is. And then my sphere is exactly the same script we had before. Rhino script at sphere, my point, radius, and 2 parameters it requires. And then printing is my debugging tool, and my awesome list. Notice all this has to be nested. Indentation has to be within this function, otherwise it will run in the range function. Then I can step back out of it to return the spheres to the output. So spheres is equal to my awesome list. There you go, script 1.5. Let's get that, and we'll pop that off. Keep going. The next script is basically, I'll turn this preview on, it's grid. So what do we have to do to get the grid? And it's interesting to see what's actually happening here. We're still left with a list, not a list of lists, which is where we're trying to go with this. But radius, spacing, and num can be used. All you have to do to make it into a grid, to extend that to a grid, let's go in, take a look at your script. I had to introduce a nested loop within the I, so not only in the I range going from 0 to num, which would be 10 at this point, if I change it to num, it's going to reference to a smaller 9, but I then does the same thing. It steps in the y direction, x direction for I, and y direction for j in our scripting, and then I'm setting my point to spacing times I, spacing times j. Same script runs through, exactly the same actually, all the way through the append, and then you've got your spheres. So you've got this gridded point. You could extend it with a k in range 0 to num. As long as you have spacing times k, you'd have this in a cube, and it would come out. Once again, it would just be a list of data. It might not be what you want. So let's close this out in this setting. Let's not get ahead of ourselves. Let's go down into this one. What's the difference between this script? This allowed us to play with it, do some strange things, and shape it differently. So all it's done is gone into the script again at ModeLabs. I'm just going to say E because there's a few people involved. But basically, giving credit to what they end up doing. They keep the script the same. They kept it in the 2D format, but they started to multiply it by importing the math tool and getting things like cos and sine, and they multiply using the I and j factors. So wherever it is, if it's over 3 and up, and y 5, it's going to multiply by 15 times cos, and then multiply that by the radius, and you can get this effect. And it'll be a mirrored effect because, as they point out, 0 times 1 and 1 times 0 equal the same thing. Let's just type in sine and see what happens to that. Another command that wasn't in the Rhino. Type in sine and run your script, as long as I don't totally mess this up. There we go. And test that. You'll see the change happens pretty immediate. And there you go. All of the information changed over. You can change. You can multiply the radius and make it bigger and smaller, just like writing in your same script and it did. but you're trying to tuck this all into one little node that you can just pop in as a cluster on your board. Then branch script is how they end up ending. I think it's pretty exciting. We've got 5 minutes to deal with it. I had a little bit of trouble with their script. The domain you can set within a panel, but I wanted to make it parametric. But this branching tool is right here, and this is where I needed that initial line. But since I piped everything, that's everything piped, we'll just end up looking at that. And you can change within this node. They've gone and they've made the S line, the rotation domain, which I can set and be parametric here as plus and minus and the minimum and maximum for the angle of what's happening. And this can be rational numbers. It doesn't have to be, what did I set the type into? Hard to see here. 1 second. Let me set the type into my S line. I'm pretty sure it has to be a geometry of sorts. It's a curve. And obviously I can tell that by looking at it. And rotation domain I left as an integer because it was working there. I guess I could go in to rotation domain type int and see what it looks like as a float. But I'm just going to leave it as integer because I got it working for me. The radius is set fairly small, and the branches and the levels are an integer each. The script is pretty nice. Without any pseudo script, here it is. Import Rhino script syntax as RS. You'll have to import random because you're going to use a random function randint to get your rotation going in 2 dimensions, and you can make your variable random. You'll need your import script context. I think you need that. In fact, I used it, and then I imported math additionally because I was running into problems with the min and max coming out of rotation domain. I found that it wasn't working. It wasn't recognizing the function. So I played around with enough going on the forums and figured out, okay, if this works for me, I'm okay with that. And it is a function that's basically a definition of drawing branch using x and a line as the attributes. Yeah, there's the script context, the escape text. If I don't get the script context, I can't get out of that loop. The thing will just keep going. So escape text is something I want to use. They show you how to script this in, and the only subtle changes were if x is set to 0, not equal to 0, but it's going to be totally different if you set your variable x to 0 as opposed to check it set at 0. So if it's false, then you can return it. But you continue in, else you're going through another iteration of I from 0 to branches. You're going to end the point by setting your Rhino script curve endpoint at a line. Your start point is set the same way. Your vector, basically just start-stop vector to build it, and then use a random in the rotation of where it wants to bend next time. And the rotation is then set through the random int, which came out of the import math tools. And I would say have the script, dissect it, read it in full detail, learn how to produce the vectors that you produced here. That's a little more complicated because you're using the variation, the parametric or dynamic rotation 1 and 2. And then the point adding, simply add that to the vector as you go. You're going to append the add line by the endpoint in the point add. And you're going to draw the branch at x minus 1 and b minus at the last item in the list. And at that point, you can draw a branch, set your levels, set your line. And because you've set it up as parametric, you can actually come in here and play with your sliders. So we've reached the 14-minute mark, which is very nice. And it will crash if you take these numbers up. I mean, it won't crash, but, well, it will. But these numbers are set small enough that I can pull up these iterations and wait a few minutes and watch them kind of shake and jiggle. And keep in mind they're totally parametric to that initial curve. So if I take that initial curve and I have to bake it out because I've internalized it. If I take that curve, bake it, and I decide, or if I left it in there, if I take that and I move it up, shake it over, twist it, well, so I don't do it in that direction. I bend it this way. If I take the one Y in this direction, then I can set that one. Once again, I go back to this vector, set one vector, actually not set. I have that one overriding it, but let's just do a set one curve. It should explode up into its form. I believe there it is. And then the new direction of what I have, and it's controllable by that point. So let's get a picture there. It's got to react to that and shift over. So whatever you ended up wanting to do with these little fractals, these practice this recursion tool, please go ahead and try it. Thanks for watching.